Hi, I'm Bob. Welcome to the Regression Analysis and Estimation Methods using Stata course. In the last two topics, we used the postestimation commands to do the diagnostic analysis after running an OLS regression model. We found heteroskedasticity in the error term, and some of the functional forms of the explanatory variables may be omitted from the model. In this topic, we will transform the outcome variable from the level form to the logarithmic form and add the quadratics and interaction terms of the explanatory variables to the model. We will use the margins and marginsplot commands in Stata to obtain and visualize the prediction of the outcome variables and the marginal effects of the explanatory variables. Let's open the course dataset bob.dta. We regress hourly wage on schooling, age, marital status, and gender in the last two videos. Now, let's use the log of hourly wage as the outcome variable instead of the level form of hourly wage. The variable lwage in the dataset is the log of hourly wage. We rerun the regression model using it as the outcome variable. Here, we use the prefix I dot in front of categorical or dummy variables. Let's execute it. The estimated coefficients are all statistically significant at any conventional significance level. Keep in mind that when we use the logarithmic form of the outcome variable, the interpretation of the coefficients is different from using the level form. When the log of hourly wage is used as an outcome variable, the coefficients are the percentage change of hourly wage when the explanatory variable increases by 1 unit. For example, 1 more year of schooling completed increases hourly wages by 13.2%, or precisely 14.2% on average, holding other factors fixed. As age increases by 1 year, the hourly wage increases by about 1%, holding other things equal. Married workers earn around 15.4% more than other workers on average, and female workers earn 18% less than male workers, holding other factors constant. The main reason we use the logarithmic functional form of hourly wage is that it alleviates the heteroskedasticity problem. We find no evidence of heteroskedasticity when we draw the residuals versus fit values plots. When we do the post-estimation heteroskedasticity test, we cannot reject the null hypothesis of constant variance of the error term. To visualize the predictions, we use the margins and marginsplot commands. We use the add option to produce the fit values of the log hourly wage at certain values of the explanatory variables. We try schooling first. The variable schooling ranges from 6 to 17. We type margins, comma, and the option add. Then we put the range of schooling in the parentheses. In this case, we want to compute the predicted log hourly wage between 6 and 17 years of schooling in increments of 1. We now get the average predictions or fit values of the log hourly wage at different schooling values. After the command margins, we usually use the command marginsplot to visualize the average predictions. We type marginsplot. The graph shows that the log hourly wage predictions increase with the years of schooling completed. We can also specify the predicted log hourly wage to be computed at certain values of the explanatory variables, such as for married female workers. We put married equals 1 and female equals 1 in the parentheses. Now, the log hourly wage predictions are for married female workers at each educational level. Notice that if we do not specify the values of some explanatory variables in the model, the predictions are computed at the means of those explanatory variables. In our example, the predictions are calculated at the sample mean of the variable age, 36.8. Today, we have learned to transform the outcome variable to the logarithmic functional form to solve the heteroskedasticity problem. We also used the margins and marginsplot commands to visualize the predictions of the outcome variables and find the patterns of the predictions against explanatory variables. Thank you so much for watching this video. See you tomorrow on the next topic. Take care. Thank you for watching this video and subscribing to my YouTube channel. See you next time.